Welcome everybody. I hope you can hear me. Maybe you can confirm in the chat. So you remember last time we left with the appearance essentially of the IBM PC in the 82, and now we continue explore essentially the phase in which the personal computers actually replaced the mini computers that essentially disappeared in the 80s, and then we shall see how they were say being used in every type of communication and others. So we ended the last time with the IBM PC, which was a huge success, even though it was later copied and imitated, and even though IBM was not really excited about it, it was developed just for covering a segment of the market which was not perceived to be very important. And in the Apple time, in the Apple say company, there was clearly the presence of Steve Jobs, which is has been always quite important. So Apple started designing a new computer that would replace the Apple II because the Apple III was a failure essentially. And so they started designing these things here, which was called the Lisa, and the name of the Steve Jobs' daughter, and which was based on the 68,000 chip from Motorola, and was quite an advanced system, but extremely expensive. These things that is above the computer is the hard disk. And so since Steve Jobs was always trying to impose his choices, he was expelled by this project, and so not having nothing to do, he focused on a small project called the Macintosh that was essentially something with the same interface of Lisa, which was, if you remember, copied by the work done at the Alto Research Center from Xerox, and but it was a extremely stripped down system, so it was a cooperative multitasking system in which essentially the programs had to say give the coin, the token to the operating system after they, for instance, initialized. Essentially, in a graphic interface, programs generally after the initialization phase are waiting for the user to do something that has to do something, say click on the menu, type something on the keyboard, and so on. So the idea of cooperative multitasking was that when idle, the programs had to give the right of executing to the operating system, which then passes again the token to the program when the user has done something that is related with this application. Clearly, this is a way of say having trouble. It is simple because you don't need chips dedicated for dealing with multitasking, but if one single program crashes, all all the system crashes. Okay, so the Apple Macintosh was say some really jewel because it was small, essentially this size, say 20 centimeters for 25 centimeters, with a 9-inch screen, like a white, and mouse, clearly all closed without any possibility of expansion. It was sold with 128K of memory and 400 kilobytes of disk, floppy disk, which could in which you could fit the operating system, possibly some application like Word, and maybe some user file. And it took just 9 seconds. I checked this personally some years ago. Took 9 seconds for being ready to work, starting from a floppy disk, before being ready for usage. And it costed not a cheap price, about $2,000, but you had to essentially add at least another floppy disk driver, otherwise it was a continually swapping disk. And okay, so it also followed the classical politics of Apple to surcharge the price because it want to fund the advertising, the promotional campaign, and also for having funds for developing new systems. So so it was really an advancement in the field, but it was really expensive. And so at the end, only when Steve Jobs was fired from the Apple, and they hired John Sculley from Pepsi, it started really to expand, because now it was the memory was increased to 512K and then to 1 megabit. Apple Talk, so it's kind of a slow but really cheap local network was added. And clearly there were also laser writer printers, which were, I'll cover them in a minute, which were very advanced devices, and a lot of killer applications, in particular the PageMaker and also the software by Microsoft, like Word, which was extremely more advanced than with respect to the DOS counterparts. Laser printers were really a revolution at that time, because it allowed to have a very careful, say, way of printing graphics with a high resolution, essentially 300 dots per inch. And it was based on clearly a technology developed by Xerox, as usual, which Xerox actually, from this technology, which was strictly connected with the photocopiers, from there they were able to gain a lot of money. Clearly, it was also copied. The printers from Xerox used a very sophisticated language for the description of the page, the PostScripts, which essentially is a very high-level language in which you can perform operation among matrices, because it uses the projective plane, say, approach. So it could be programmed really. Andrea also said, but I don't know, Andrea. I'm sorry. I've seen that you were trying to enter. Just a minute. See? Yeah. Okay. I think it is only a problem of your network, because others seems to be here without problems. And okay, so the applications were essentially driving the market. The Apple II had the Apple Works, clearly using a character interface, but Macintosh had graphics, so MacWrite, MacDraw, MacPaint, while, for instance, in the PC world, again using a character interface, there were essentially business applications like a spreadsheet framework, which was including a spreadsheet, a text editor, and database, and so essentially there was this perception of being two different words. For instance, a framework tried to emulate using characters a windowing interface. You see, you could have windows with menus, but all drawn using characters, while the real Macintosh applications were graphics. And also, IBM PC could have two modes, text or graphics. The initial resolution was extremely low, 320 by 200 is really very low. And so essentially all applications that were not, say, needing something like real graphics like AutoCAD or Ventura Publisher use the text interface. But mainly using the 68000 chip by Motorola, it had, and there were already computers with a full graphic interface like the Atari, and in particular in the CP/M world, the GEM graphic interface, which was essentially copied directly from the Macintosh, and I used it on an MS-DOS. Clearly, you need to have a mouse, which was not really common at the time. So I remember using this software without mouse. It was really a pain. So okay, so the IBM, which was not satisfied by the IBM PC because it was essentially copied by a lot of other enterprises, and it was really low level. So tried to develop a new version, the PS2, with a very good hardware and also a very interesting architecture, which was really multitasking and so on. But it was developed together with Microsoft, but the IBM committed again the same error to, like in the system 360, to announce this new technology before it was ready. And it has also a bad time because this system needed at least 3 megas of RAM. And you can observe exactly at launch the prices of RAM at the sudden rise. So essentially this hardware, which was good, was too expensive. So I remember I had one of these using MS-DOS, and it was really robust, well done, but extremely expensive, clearly, from university. On the low level, the Commodore, after the 64, developed the Amiga, which was really a good interface. It was a real multitasking operating system with graphics interface. And the problem that is that the Atari, the Commodore, was not, which was also bought by Atari, or vice versa, I don't remember. They had a lot of troubles with the organization. You remember the Commodore had always the problem of being having a lot of malfunctioning things, so they had to be returned and so on. And also the Amiga, which was for what I have read. I have never used it, but it was a really good system with, say, a chip for making music, which was widely adopted by musicians. It was also quite cheap, but essentially was never able to take off. And finally, it was closed, reopened, reclosed, and so on. And so, without Jobs in the breaking, say, the plans, Apple decided to use the desktop publishing enterprises, so the sector, as the, say, main target beyond the universities. I remember having worked in that time in a software in a computer house essentially dedicated to desktop publishing, and so essentially with a laser printer and a new, more powerful Macintosh, you were able to essentially produce low-level publications using Word, Photoshop, and then Adobe Illustrator for making illustrations. And so essentially it was quite a mature system. But in the meantime, 85, Microsoft started to develop his own graphic version, Windows. Remember that at that time, Windows is a completely different thing from what is Windows today. The interface may be roughly similar, but the structure was completely different. Windows was running on the DOS, so it had the same limitation of DOS, and essentially it could run DOS in a window. And so the first version of Windows was essentially not usable. If you want, you can go to this site here, pcjs.org, where you have all or most of emulators of operating system and computers of the time. So you could run Windows 3.1 or Windows 2, maybe also Windows. Okay, you have here all kind of Windows. So essentially, this is a quite a sophisticated version of Windows about the end of the 90s. So with say standard things that overlapping Windows. Okay, so you could run clearly DOS system, and you could say launch file manager and so on. No? While, for instance, if you run Windows, the first version of Windows, you see that, for instance, it had non-overlapping Windows. So if you launch something, I don't know if I remember, so for instance, Paint, it had to occupy all the screen, because you could not have more than one application using the screen. So it was graphics, but in a very limited way. And okay, but you can play and have a feeling of being in the 80s and 90s, and only with two things. First of all, we have started in the Intel world with the 8086, which was a 16-bit processor. Then it appeared the 8286, which was a processor which could run multitasking systems, but essentially it was used only as a faster version of the processor. With the 8386, this was really a mature processor. For instance, the Linux operating system was developed on this architecture. So again, they started to write down Windows, that is Windows 3 and 3.1, which essentially exchanged its role with respect to DOS. So while this Windows was run over DOS, in this other case, it is DOS which is run in Windows. And mainly Microsoft developed Excel spreadsheet, and for developing, so essentially most of the functions of Windows 3.0 were developed having Excel in mind, which was the real killer application. And I remember that at that time, when you installed Excel, it also replaced a lot of functions from the standard Windows, so that if you, instead of installing Excel, you wanted to use another spreadsheet like 1, 2, 3 or others, you had worse performance with respect to installing only without, or even without using Excel, because the improved libraries were provided with this application. Clearly, it was extremely incorrect to do. And the other fact that happened in the 90s was that Microsoft decided not to follow IBM. So Microsoft always had several projects at the same time. The IBM wanted to shut down DOS and replace it with OS2, while Microsoft it was not considered as IBM by the clones, because all clones had to buy DOS or after Windows to run. So Microsoft was quite content on having a varied market, and so Microsoft developed with IBM OS2, but in the meanwhile, he was developing a Windows, which at the end was sold independently of IBM. The other things that started to do was to buy or copying the successful software. So, for instance, at a certain point, it appeared as things like Stacker, which compressed the file. The hard disks were extremely expensive at that time, and a lot of space was, say, consumed by files only for in a very inefficient way. So Stacker was an application that transparently compressed the file on the disk and compressed when it was used, so that apparently you had a much larger file system. And so Microsoft first tried, for instance, to buy Stacker. When this company refused, Microsoft developed a similar things and integrated it into MS-DOS 6.0, so that Stacker ran out of market. And this also has been done for a lot of different parts. And so clearly, at this point, Microsoft began to earn more money from the Office suite, so Excel, Word, PowerPoint, mail, and so on, instead of the DOS operating system. And at the same time, started to relaunch BASIC as the standard script language, so that clearly it used to sell, for instance, a Quick Basic, but also to include BASIC, Visual Basic, as the scripting language of the Office suite. So as it is today, so that you could develop a custom macros on Excel, or automatic macros for Word, and so on. Clearly, this also opened the way of having Visual Basic viruses on your Office. So you could send a Word file with macros written in Visual Basic, and since these macros had the power of opening other files, they could copy themselves in other files and finally infect all the system. And so the diffusion of PC with this very low level operating system, because essentially the problem was that the DOS and Windows operating system had not the protect level of standard, say DEC, VAX, PDP, or Win or a Unix system. In Unix, you could a standard user cannot write to a system file or to an executable file owned shared by all users, while in the DOS Windows system you could do anything you wanted. So the viruses had really an easy way of spreading, simply infecting executables, and every time an executable was run, it was able to infect others. They could also infect the floppy disk, because in the floppy disk there was a sector which was loaded in memory, and so it could store essentially the executable, and clearly this is the beginning of viruses. And as you know, viruses can be thought as composed by two parts. The first one is the virus itself, so something that can an executable that can infect other files, and then there can be a payload which can be used for doing several things. For instance, it can be used for launching a denial of service attack. So when you have contaminated a sufficient large number of computers, you can say have a bomb that says, okay, at that time every copy of the system connects to a given service, so that the service goes down, like for instance a web service. Or it can clearly look for information like credit card or something like this, and send it to some in some place, or install, for instance, a web server that can serve for, I don't know, pornography or other kind of things that you don't want, or stolen software or something like this that you don't want to store on your computer, or open a backdoor. So like in the War Games movie, that can be used to use your computer by someone else. And finally, but this is most recent, to use cryptography in order to encrypt file and demand ransom for decryption, as or clearly other usage are say stealing information. And the other things that computer virus do, for instance, is to exploit things that are seen also in real computers, in real viruses, to say try to escape from identification. You see here, because clearly the first solution for avoiding this contamination was to develop a system that screened all files looking for patterns and possibly correcting them. The idea is to have ways of shuffling, for instance, the instruction in memory, or replacing instruction with other which equivalent, in order to mutate and escape from identification. And so there are a lot of interesting aspects to be studied about computer viruses. For instance, a very interesting paper that I read some maybe probably 10 years ago was about trying to identify viruses that were transmitted through the network, say like for instance as attachment to email system. And what was discovered is that even after years and years that a given, say, operating system disappeared from market, still occasionally some virus appeared, essentially because someone has turned on an old computer that was left somewhere, and this old computer was infected, and the first things that an infected computer does is to try to send out other copies of the virus. Okay, so clearly viruses has also been used as military tools. For instance, Israel used the computer virus to destroy the centrifuge of Iran when Iran was trying to purify some nuclear device, some nuclear fuel, because essentially, and these are high-speed centrifuges because they have to separate isotopes of uranium. So the difference in weight is so smooth that you have to use a very high speed. And Israel was able to infect the computer controlling these centrifuges in order to have them run at a faster pace, and so they break down. And I remember a similar thing was a virus who tried to destroy the hard disk of computers, starting to scratch the head up and down, and trying to say tear the hard disk. And okay, so that is a really interesting things that can be done with computer viruses, and but these are things that can be easily used only with bad done operating system. It is very difficult to have viruses in real multitasking or real, so we have well done system, except Windows, because the present Windows is a very mature system. But since it was born having the old Windows in mind, it was not programmed to have a strong separation between operating system and user, because the idea was that no user wanted to had to enter a password just for installing, say, a new software. So the idea is that the standard user in Windows is a super user. It can do anything. So clearly also programs launched by this standard user can essentially destroy all the operating system. And okay, another important revolution was relational databases. The idea of relational databases is very similar to having a kind of spreadsheet. So each table is a set of, say, columns labeled by some identifier. And so, for instance, you could have a student table with fields name, ID number, address, and age, a courses table with the course ID, course name, and the teacher name or subject or something like this, and also another table that had an ID number for the student, a course ID for the course, and the grade. And then if you want to know the grade of students with the surname Bagnoli in physics courses, you can use something like this so that you can select what you want to be printed. So name, course ID, and grade from tables. Student, course, and grades from table students, courses and grades, where the name, here is an error, contains Bagnoli, and course name contains physics, and the ID number of this table is the same as the number of this table, and so on. So essentially, this is the SQL syntax in order to, or one of SQL syntax in order to deal with this relational database. And another, say, things that appeared at the end of the 90s was in some way coming back to the era of mini computers, because first at the beginning of this decade you had servers, generally mini computers, with the terminal attached. The dumb terminal, in the sense that the terminal was only used to show the screen and to enter something, but it has essentially little power of elaboration. Then in the 90s, there was the home PC revolution, so that, for instance, enterprises were throwing away the terminals and install the PC. And then, but then you had to essentially move files from one PC to another, or work all together on some common application. So, for instance, in the old MS-DOS, you also had the terminal emulators program in order to behave like, so have the PC behave like a terminal. But then a new concept arose, that is to develop an application in which the burden of drawing the graphic interface and maybe performing some task was done locally, I mean in the terminal, while the data are fetched from a server. So the server had only to be concerned with giving the right data, while all the heavy task of drawing the interface was done in the PC. And this is essentially the concept of client-server application, which is essentially behind any browser today. And so, but clearly, this was not done with the browser, which is a generic interface. It was it started to be done for each service. For instance, I remember going to the bank at the beginning of this decade and having terminals with all the digits. Then, after some time, the terminal was replaced by a computer with Windows, and in the Windows, a similar terminal was run, but in this case, the update of the screen was done by the computer, while only the data contained was done, so the data was obtained from the server. And so, for instance, this is an example of an interface, in this case, for a database. Now, the problem with increasing performances of the home computers in the world of IBM compatible computers was that the design of the case was still that of the first computers. And this also established where the main board had to add all connectors and so on. And so Intel could produce more powerful chips, but the number of devices that could be placed on mainboard was still ruled by the standard imposed by IBM. So at the end, Intel decided to develop their own motherboard so that they could introduce a more powerful buses, for instance, the PowerPC buses, a dedicated slot for the graphic machine, more interfaces could be embedded inside the motherboards, and so essentially they were free to develop new connectors, the IDE connectors, for instance, and also to tell the constructors of the case where to provide holes for instance, plugging the video connector for the monitor, the USB, the audio connectors, and the PS2 connectors for mouse and keyboard, and so on. And so essentially, this began to so Intel began to take the role of the also designer of motherboards, not only Intel, and also others. And finally, thanks to miniaturization of components, it was possible to develop the first real portable, so laptop, a portable computer, not only transportable, but things that run on a battery and that weighted some 5 kilos or something or less, and that could run on battery for say 2 hours or something like this. And these are two examples of the beginning of this decade. For instance, this is a power book by Apple. I used one of them, was really nice, quite usable. This is I also had something like this, a ThinkPad with this very bad mouse on the stick, on the say point mouse, but the rest was not bad. Clearly, we still don't have a touch pad. And clearly, the other things that was trying to improve was the power of the CPU, and again the lines were essentially two. One, to had very rich instruction set, the CISC. For instance, VAX had one of the more sophisticated instruction set. It was really, I never used it, but I know that it was really easy to write down something in assembler. But the problem is that all these very sophisticated instructions actually were run in microcode. So essentially, there were small programs inside the CPU. That implied that the CPU had to run much faster than the rest of the hardware. And so it started a competition for having the fastest CPU, which meant also those that dissipated more power. While on the other side, there was the idea of developing less powerful CPUs, but which consumed also much less power, with a restricted instruction set, all instructions with the same size, so that for the compiler was quite easy to optimize code. And I remember, for instance, running one of these, I don't remember if it was maybe a Spark. It was really a change. Every time you install the new version of the compiler, you saw the same program running faster just because it had a new optimizer. So here are examples of RISC from IBM, from Sun, from Silicon Graphics, and this I don't remember, maybe DEC, no, HP. And so this was the final trend, which is the one who is successful today. And but at the first, in the end, so in the 90s, essentially it seemed that the right way was that of Intel, so that also Sun and Macintosh started to switch to other kind of processor. Macintosh first tried the PowerPC processor by IBM, the one that was developed for OS2, but at a certain point they had to abandon this because it was not being developed anymore and passed to Intel. While also Sun, who developed its own chips, at a certain point also adopted the Intel chip for some of the low-end product. And but this continuous changing of the hardware platform was not, as usual, accompanied by a well-developed operating system, or developing improvement in the operating system, so that at the end one had the impression that, okay, the chip is very sophisticated, but the operating system is not exploiting this power, and at the end it was slow. And so this was one of the problems that led to the dominance of Microsoft. In the meanwhile, Microsoft, which was quite successful, had a terrible problem because when the line started from DOS, Windows 3, Windows 98, Windows ME, Millennial Edition, was a dead end because it was a very bad operating system from beginning, essentially the same, not very different from what also Apple offered. Essentially a cooperative multitasking system in which a single application could crash the whole system. But in the meanwhile, the DEC was failing, and I remember it was quite a shocking news. In the 1998, it was acquired by Compaq. Now, Compaq was a producer of clone of PC, while DEC was such a big company with a very sophisticated mainframe, not mainframe, mini computers, but very large mini computers. The physics department was full of VAX, and the whole ENFN network was running on VAX. So it was quite a shock. Also considering that it had just released the Alpha processor, which was a really extremely powerful 64 processor, that I remember we just bought a certain number of workstations with this Alpha chip, which were extremely fast, but it was not sufficient. And also Compaq, which both the Alpha then abandoned in favor of Itanium, and then also Compaq failed. And but this was quite a chance for Microsoft, because he could hire a lot of engineers from VAX, among which Dave Cutler, which had just developed the system for the Alpha chip, and which essentially were charged of developing a system that apparently was like the old Windows, but at the end was the VAX, the DEC system, VMS system. And then so the Windows NT, which at that time was a system, an operating system essentially for servers, even though after some time also the workstation version appeared, was essentially the operating system by DEC with an interface like Windows, and clearly with the possibility of running DOS and Windows program in a box. And clearly Cutler hated Unix because I shall explain in a few moments, but Unix was developed essentially from a base, I say, from hackers that implemented the various portions. Clearly, then it was integrated in some big, say, assembly like System 5 of Berkeley, Unix, and so on. But essentially, it was something that was written from, say, from users, while VMS was a top-down project with, say, engineers who designed all aspects, and so it was much more sophisticated, also much less flexible than Unix. So Cutler hated Unix, and so it was not concerned in having something which was Unix or POSIX complaint. And so still Windows, the present Windows, even though Microsoft says that it is POSIX, so Unix compatible, it is not. And finally, in these last years, also Microsoft essentially abandoned the Windows for the server, and now is recommending using Linux or some kind of Unix. Actually, it is not the first time. Windows, Microsoft also developed a kind of Unix called Minix, if I remember. No, not Minix. We shall meet in the following. And okay, so from the processor point of view, the real so after the 8086, the 8286, the 8386, the 8486, at the end Intel switched to Pentium, even though Pentium clearly was intended as an 8586, which actually appeared as a CISC, but was really a RISC using some kind of emulator. And so this is the line, the development line of Windows. You can see that they started with DOS, which continued with the old line of Windows. In the meanwhile, they collaborated with IBM in the OS2, but this was a dead end. Clearly, part of this was then ported to Windows NT, which is VMS. And then you can see that now we are essentially here with this Windows, so the second Windows generation. And so essentially the switch from here to here is from cooperative multitasking to preemptive multitasking. Preemptive means that the right to run can be taken from any process at any time without having the need of alerting the process, or even though the process has blocked. And clearly this uses a lot of more memory. For instance, the Macintosh operating system, which was a cooperative multitasking, was extremely well done, because instead of addressing directly memory, so for instance, a program had a need for some portion of some space in memory, and so generally they ask memory using a malloc, calloc, something like this, and then it receives a pointer. so that portion of the memory is blocked. But clearly the total amount of memory is finite, so the solution are two. One, which is used by modern operating system, is use virtual memory. So okay, you have this address, but if I need this part of memory, this is moved on the disk, and this is free for being allocated. Virtual memory can be done also in memory, moved from some other place, and so on. The other was that used by the Macintosh operating system, which used an indirect pointer, so that instead of giving directly the address of the allocating memory, it was giving a handle to the address, so that memory could be moved and handle updated, and still programs could access to the needed memory. So it was a nice trick to save, for instance, the need of having a chip for managing the virtual memory, but clearly it was required for programmers to always use handle instead of using directly pointers. Otherwise, clearly the computer crashed. And okay, so what did Steve Jobs after being fired by Apple? He launched a new company called Next. Clearly, it was also participated by Apple, also by Microsoft, and so on. And so this Next company started to produce some very interesting things. First of all, it was producing a cheap, a dedicated computer for videos. Essentially, it was a computer that aimed at, say, animation. It was clearly the core of Pixar, and it needed another workstation, a sun workstation, just to have to behave as a front end. It cost a lot of money, but it sold a certain number. So clearly not really a large amount, but it was a parallel computer, and with clearly an excellent operating system. Also, workstation, next step, which was quite popular in the academic world. It was a real mature system with very sophisticated interface. You can see it is extremely modern for that time. Windows was very worse than this. It was a Unix system essentially at the end, and it was the ones used by Tim Berners-Lee at CERN to develop the Mosaic and the first the web, essentially. And clearly this is as we shall see, the core of the new Macintosh operating system that replaced the old one, in the same way as Windows NT replaced the old Windows. So Apple was almost at failure because it was insisting in copying the PC. Essentially, all these Macintosh, also this one, this one, essentially they were imitation of a PC with expansion slot and so on, but more expensive, clearly with a nicer operating system, but essentially Windows had the possibility of, say, doing the same things. All software was ported to Windows. And so Apple was near failure, so it fired Scully and restored Steve Jobs. Steve Jobs required Apple to buy his own Next, and started to, as Steve Jobs, to launch a number of things that appeared as really as a new way of thinking to computers. For instance, the iMac, which looked like an old style television, the iBook, which seemed something like it was like a toy in some sense, all with the colored plastic and so on, and clearly with all kind of revolution. No floppy disk, only USB, as usual. Clearly, Microsoft invested a lot on this because the idea of Microsoft was to use Apple to test new things and then port to Windows. And so after, you remember, no, Apple aimed at desktop publishing. Now the new say market is movie and music. So Apple launched the home system for making movies like Final Cut iMovie, and clearly with a new operating system, which was essentially Next. And now and finally, the big revolution was to aim at music. So iPod with several different ways. Now with passing to Next, it was much easier to change the chip because it was a real operating system, almost independent of the chip. So it could abandon PowerPC from IBM to Intel chip and then develop their own one. And in the meanwhile, also the console market was essentially profiting of the new processors. So, and essentially, this was where new ideas about the processor was developed, because the idea was to have things that possibly did not require a fan. There was also like the Xbox, essentially PC that were camouflaged as consoles, but the real consoles was something that had to be, first of all, had to start quickly because nobody wanted to wait for the operating system to be charged, and also possibly without fan. So they started to use heavily the RISC based on ARM chips, which was a line developed from many times. If you remember, in Britain, you remember now Acorn, where they saw a lot of chips and say, okay, we can replace all of them with just one custom chip. And so essentially this is the line. Clearly, Apple invested also in that end of the 90s in ARM. For instance, they developed a device called a Newton, which was a pad, like the iPad, essentially. With a stick, you could draw on this. Clearly, it was a failure, but at the end, it originated the iPad. And also now, the new silicon chips, which are now extremely powerful, are essentially the architecture. They have a lot of cores, but they are essentially ARM chips. And so clearly, now with the new power, we are still jumping up and down in time in order to cover the development of a given technology. For instance, videos are not new. They are not appearing in the 90s and 2000 years. In 78, for instance, in MIT developed something which is essentially Google Maps. So they were mapping a city using a portable camera. So, and then they developed a system for navigating these movies. As clearly, they were on a laser disc. They were not so interactive, but you could navigate a town just looking at what happened in the town. And for instance, another movie that was another application that was successful was movie. For instance, Tron 82 was the first one of having full scenes, so 12 minutes, 15 minutes, drawn in CGI. Clearly also Star Trek, Star Games, and so on. But the idea was to generate all these images by software. And clearly, this was extremely expensive because at that time you need a Cray XMP, the most powerful computer of the world, and it took 10 seconds to generate an image, and 10 seconds on a Cray was really a large time. And but the miniaturization of chips also produced a new kind of say popular devices, like for instance translators, chips that could speak, chip for music. So essentially, clearly we are still going back to the 70s. For instance, I remember in the 70s, the dream of all people interested in music was the electronic keyboard that could generate or imitate a lot of instruments, and clearly this is reflected also in the music. So first, the synthesizer were using small pieces of magnetic tape in which was recorded some note of an instrument. So when you pressed the keyboard, they had this small strip of magnetic tape charged, someone loaded into a head, and so it was a really cumbersome way of say making a synthesizer. Then clearly all this sound was sampled, and the sound was generated by electronic means. And clearly again we have the Amiga, we have Yamaha, so we have Roland. So for instance, the Talking Heads concert Stop Making Sense used when it was played as a theater event. It used a kind of sound machine which changed completely the way of say producing music, because it allowed it to have a very say very fast drums, which was not possible using the human players. And so if you have time, I suggest you to go to YouTube and start listening at the music of from the 70s to the 90s to appreciate the introduction of different electronics. Clearly, in the meanwhile, there is also always the coming back to the old sound. I don't know, there are groups that say clearly groups that profit of new technology and groups that comes back to the old ones. And another revolution that lasted a bit more, but not so much, was the CD-ROM. Clearly, it was a digital revolution because you could say replace the old analogic long playing disc with the digital one, which had advantages and disadvantages. The advantages was that it was digital. It could be, say, survive scratches and damagement, and could be at the end copied. But the disadvantage was, and clearly it had a full separation of channels, because in the old analogic stereo, the left and right channels, which were coded by making the movement in horizontal and vertical direction of the head on the disc. They were not completely separated because you could not move independently on left, right, and up, down. So the stereo effect of the old long plane was limited, while here you had the two completely separated channels. And clearly, I remember that now started to appear, for instance, instruments that moved from left to right, or you could appreciate really the distribution of instruments in an orchestra. But clearly, in order to have digital sound, you have to sample the the, the music in a certain number of levels, and clearly purists like Neil Young never appreciated this idea of replacing a continuous analog system, which always had some kind of noise. I remember well cleaning the disc, replacing the head, so it was but the problem is that if you could not simply sample sound with, say, 24 bits precision and put it on a disk, because it was too large, the amount of information, and so it was needed to have a lossy compression in order to no, maybe the first CD was without compression, but then soon started to appear CD with compression, and this is the way by which music could be stored on portable device like iPods and not iPods. Okay, on the Apple devices, maybe iPods, I don't remember the one, and transmitted on the internet. Another clearly technology which now seems extremely old is the fax machine. I mean, digitizing and transmitting things on the on telephone lines, essentially, which is extremely old. This is, I think, one of the first fax sent. But if you imagine that still in 2018 there was about 20 faxes in the public administration in Tuscany, and still you can see in many public documents that you can send documentation by fax. And so just other application of electronics are in digital cameras. Kodak was one of the enterprises which developed, for instance, CCD sensors or application of CCD sensors. And finally, Kodak never recovered from this investment, because the idea of Kodak was to develop digital machines and having people print on their technology. But actually, what happened is that people use the digital technology to take photographs, but never print them, or very rarely print them. And finally, digital cameras also lasted a limited amount of time, soon replaced by mobile phones. So essentially, you had no camera that can make a phone call, but you have all phones that can take a picture. And clearly, also digital movies are quite a revolution, because if some of you are quite old or sufficiently old can remember that the first home videos used magnetic types like music, but differently from music, there was too much information in a television screen, which was drawn line by line, to have a tape which could say essentially turn fast enough to stay in the same speed of the electronic beam to on the screen. So essentially, and this required a quite sophisticated machinery in order to have a rotating head with a rotating magnetic head and have these lines of information stored in a skewed way on a large, so about 1 inch tape. And I remember well having these cassettes, this tape box with so losing the tape, also because the VHS was not the best way of storing the tape. The beta was much better, but because it had a way of turning in the same way, the controlling better the speed of the tape. But the problem is that while VHS was released freely to could be copied by any producer of say the devices, the beta was closed by Sony, and so it was not quickly adopted, and clearly the VHS replaced the market. But all the VHS lasted, I don't know, some 15 years, and then it was quickly replaced by DVD, digital video disc, which is essentially a CD but with so shorter wavelength, and so that it could store more information. Clearly, then it was replaced by HD DVD, then Blu-ray, each one lasting, say, less and less time. And now, I don't know if I can buy a Blu-ray. Blu-ray lasted really, oh, I don't know, 5 years or something like this. And another problem with DVD was that the movie world was concerned of having this copied, and both from one country and sold in another country. So, like happened with the CD, so they inserted the regional code. You could not buy a DVD in USA and play it in Europe, and clearly people started to say, okay, if I cannot do that, I will use piracy DVD without, so instead of buying, say, two players. And but clearly each of these steps is accompanied with a higher resolution, and also clearly the need of changing television. So for instance, you can see here, this is the resolution, so at fixed resolution, actually it is the number of pixels of a video CD, a video that could be stored on a standard CD, DVD. Then they switched the two numbers, so 720, 1080, or 1080. And clearly now we have a 4K, which is clearly not real, because it is a 2K, because it is the double sides linearly of this of 1080. Clearly, if you square it, you can have a 4K, but this was not the relation between 720 and 1080. And clearly, there are a lot of other phenomena that I can skip. But for instance, I remember that time it started to appear devices like TiVo, which allowed television program to be locally stored, so that one could skip advertisement. So it had a button for skipping 30 seconds, and then clearly there was the rise and fall of Blockbuster, which started renting tapes, VHD tapes, and then DVD, and then disappeared quite quickly. And clearly now, the other, with the increased speed of internet, essentially, the development of quite compressed formats like MP3, digital music in the sense of something that could be virtual music rather than digital music, because music was already digital with the CD, but now it started to be sold or copied without being carried by a given hardware support. So you could subscribe to Napster, which was a system of sharing links to music files that are then transferred from using a peer-to-peer mechanism. It means that even all people could let other people copy files from their own hard disk, and Napster only furnished the indexing of these files, and yeah, this could become possible because of the improvement of the speed of the network, the improvement of the storage capacity of the computers, and also because new file formats were developed. Clearly, developing a new compressed file formats also means that computers are more powerful, because you need a lot of power to compress the file and decompress them. So everything is connected. And clearly, the Apple was the first to understand that instead of fighting against these systems that allowed people to listen to virtual files, it could be constitute a new market. And so Apple opened iTunes and started selling devices that could be used to listen music, and could download music only from certified services. At least this is the idea. And clearly, as I said, the core of all these things that you have seen here is the ARM processor, which is the core of iPod and so on. So you can see that Apple invested a lot on this, developed some failure like the Newton, but at the end it was able to make profit of this investment. And these systems use the ARM and a lot of field programmable gate arrays, which means having generic chips made by a lot of things like this, in which you can have some logic device, some lookup table. So it could be programmed to emulate other software. Clearly, you don't exploit all of this software, because in some piece you just choose to use a lookup table, in other just some digital filter or so. But it is much cheaper to produce in mass a large number of these on a chip than to produce custom chips with only the needed pieces. And this is essentially how we now use. And clearly, again, using this new hardware, allowed to recover a lot of studies. You see again, you appearing years like the 70s, the 80s, which in which say virtual devices were developed without the possibility of being really used. But now you see that things comes back from time to time. Clearly, virtual reality has been tried. I remember, like a 3D movie. They continues to appear, not to be adapted. Then you wait some 10 years, and then again you have 3D movies, and you have a virtual reality, and you have a Google Glass, now Apple Watches. So now Apple Watches, no, this has established, but the Apple Googles are again. So I don't know if they will be adopted massively this time or not. And really, with all these promises of virtual reality, there have been during the evolution a lot of effort to develop 3D interfaces, both a lot of in movies like Minority Report, Johnny Mnemonic, Jurassic Park. But for instance, in Jurassic Park, there is a scene in which the computer manager escaped, so all cages are left open, dinosaurs are eating people, and they are able to find the password to unlock the system. And there is this young girl say, "Oh, this is a Unix system. I know the Unix, so I can use them." And actually, we see a real file system of a Silicon Graphics station, which is extremely unusable and extremely slow if you watch the movie. But this was one of the effort of developing a 3D interface, which still is not used. The desktop is just a metaphor of a system, but it is essentially 2D. Okay, we shall see what happens. Essentially, the problem is you can, for instance, have a look at Minority Report or Johnny Mnemonic. They are extremely, say, heavy from the physics point of view. If you manipulate things by grasping them already, you are essentially becoming exhausted after 10 minutes, and it is very different from typing on a keyboard or moving a mouse. And the other source of improvement, and actually this is the real improvement in the last period, come from games, because first of all, the games needed to find a way of representing something with a sufficient graphical rendering with low hardware. Silicon Graphics was aiming at developing a very sophisticated workstations for drawing 3D scenes and so on. But clearly, people did not want to buy a Silicon Graphics workstation of, say, some $2,000, $20,000 for playing Doom. So they may want to buy a new graphic card in order to have a better resolution, but that's all. And clearly, so the market of graphic and accelerated cars was driving the market in the 90s and the beginning of 2000 years. And but also a lot of interesting tricks. For instance, you can have a look at Wikipedia. These fast inverse square root is in some, so this is the line, and in some sites you see that this is the line who ruined the Silicon Graphics, essentially because Silicon Graphics was aiming at furnishing a very realistic 3D scenes. For drawing a 3D scene, you need to compute a lot of times the 1 over square root of x function, which is a function that has to be computed using a table and a series of approximation. Then in Quake 3 code, here it is full of errors, code, there is a line which is exactly this one. So you take a number, you shift it by 1, you subtract by some funny constant, and this approximates quite well the square root of x. Clearly, only with the 32-bit numbers with a given representation, but this is something that takes really a few so clock time in any computers, while this one takes much more and needs a specific mathematical processor. And so someone said that this line of code was that brought SGI to failure. But on the other hand, the pressure for having faster and faster and more accurate graphic card led companies to develop a kind of computing capabilities. NVIDIA developed the idea of making a lot of computation like geometric transformation, ray tracing, etc., just on the hardware of the graphic card. And at the end, since they are mainly dealing with physics, and physics is essentially almost all physics can be traced back to a local interaction. The idea is that you can have a parallel processor with limited power, but connected in the right geometry, so that you don't have to transfer data from memory to central unit and then unit to memory, but just communicating among these processors. And with them you can do a lot of computation, like for instance simulating a fluid or tracing light. And this is the birth of GPUs, which now are sold without the display for making, say, neural networks and all kind of local computation that can be done in parallel using local data, essentially. Okay, then clearly we have also the improvement of consoles, and for instance, interesting. There are really innovative consoles like the V1, which developed a completely new way of, say, interacting with a computer. Other much more traditional, for instance, are the Xbox from Microsoft. This is essentially a PC in a box with a chip in order to forbid to install other operating system, which because clearly, as usual, the Xbox was sold by Microsoft at a lower price than the production one, in order to bring down the market of other consoles. But clearly, the Microsoft had the fear of people buying the Xbox and using it as a standard computer, instead of buying another computer. And so it put a chip in this forbidding, so avoiding, so making impossible, or at least difficult, to install another operating system. But at the end, this was cracked, and so you can now, if you are interested, install Linux, for instance, on an old Xbox. And so we are now at a turning point, because in the 1996 something new, really new, appeared. Clearly, it was an increase, so a step by step increasing up to a kind of phase transition, because at CERN they used to have a lot of documents that have to be shared, like manual, reports, and so on. So all these documents had their own format, but the preferred one was a textual, not, for instance, using PDF or PostScript at that time document, because clearly in PostScript you could print them, but it is much more difficult, for instance, for searching for information. So the idea was to have a text document, but a text allowing to have, for instance, a hypertextual connection from one document to another, and the possibility of putting images. So there was already a lot of studies about describing a document from an abstract point of view, and not in a way, for instance, that was used by the editors. For instance, Microsoft had a way of saving a document using a rich text format, which is a format with codes, text codes, something like TeX, that specified the formatting of the text. LaTeX or text, more text than LaTeX, was another way of saving a text document with codes, with instruction how to format the text. But on the other hand, there was studies about a way of, say, specifying the logic structure of a document. So this is a title. Then there will be a way of, say, printing a title in bold if you choose this style, or in red if you choose another style, or using some font. But the main concept was that this is a title, this is a paragraph, this is an image, this is an emphasis, and so on. So at the beginning, Tim Berners-Lee was, say, trying to put it all together, and so he just used a very stripped down version of this way of specifying what is called the page markup language. And so he developed the first HTML, which had a fixed way of representing. So you could specify this is a heading of level 1, and this was printed in bold. Heading of level 2 was printed, I don't know, with slanted type, and so on. But it could allow for hyperlinks. So this text is a link to another document. The way of, say, here there is an image that you have to retrieve from this link, and so link dotted list, and so on. And while developing this, he had also to develop the browser. So the concept of the browser, clearly at the beginning, putting together a lot of existing software, so that it was called the Mosaic, because it was a collection of different pieces. And because there were already ways of searching for information, for instance, using the Gopher protocol, but at the end, most of these existing protocols were abandoned, and only the essentially the HTML with the corresponding server was surviving. So the HTML starts from these generalized markup languages, but which is quite more old, but it was missing essentially the idea of hyperlink. So the idea of HTML is to have, so the modern view is to have a structure where things are defined by their logic meaning, and then you have, so this can be also read as a tree, which is called the DOM, the document object model. And then there is an accompanying file, so the database, which is the cascading style sheet, which says how title has to be represented, given, for instance, the output you want. For instance, you could ask for a different representation for printing or for screen, or for people who are visually impaired, so that this has to be represented as sounds. So, for instance, with a speech synthesizer, and so on. So, this with the style sheet, you can change how the same text appears just by changing their representation, and so this is essentially the birth of HTML. Clearly, markup is not a new concept. For instance, you can use different ways of LaTeX or tech, or there are many. For instance, also Wikipedia has these own ways of specifying markup, and also every say editor had the way of marking text for having a different representation. But the innovative thing is to separate the description from how it is represented, so that, for instance, now we have a full specification XML of specifying pieces of information using a similar syntax, without having any need of having this corresponding to some visual interpretation. So, okay, I think we can skip, but I don't want to skip, because, for instance, Word, which clearly started thinking only at, say, formatting text for the screen or for printing, can export text using HTML, but it is not a conceptual HTML. It is just the HTML which reproduces the visual appearance of the text, so that there are a lot of custom formatting of this piece of text, instead of relying on a style sheet. So you, for instance, this say, okay, this piece of I don't know, here, this piece of here, actually it is nothing inside. A lot of instances in where you have piece of text formatted in some specific way, and not being part of a more general style, for instance. This is also because, for instance, in Word you can take just a word and format it in a completely arbitrary way, not being obliged to use some style. Clearly, in order to use these HTML, you need the server. The server can use either some existing protocol like FTP, but which is quite heavy, because FTP was designed to have a live connection until it is dropped, by which you can transfer file, you can request a piece of file which was corrupted, and so on. While the HTTP protocol is much lighter. It opens a connection, transfer a piece of information, then closes connection. If you want something more, you have to reopen the connection. Clearly, there are improvements to keep a connection open, because, for instance, you can first ask for a document, then for all images, and clearly it is much faster to keep the connection open and to transfer all of them one after the other. But essentially, this is an improvement over the standard protocol, which says you establish a connection, you transfer things, and connection is closed. The server has no need, in general, of keeping track of the client. Clearly, this has a lot of drawbacks, but I think that for today it is enough, and we shall continue maybe next lesson, which will be next Thursday, but in the morning, because I'm engaged the next Thursday. So I propose you next lesson to be the Thursday 6, but at 10 and not at 2:30. Do you agree?
Okay.
Okay, so the last lesson, I think that we shall not finish all the material, but it is not very important, will be the 6th of June at 10 in the morning. Okay? Okay.
Okay.
I can copy this link suggested by Mattia, which evidently already knew the story of Quake 2 inverse square, Quake 3 inverse square. So see you for the last lesson. Bye bye.
Okay.
Bye. Thank you.
Bye. Thank you.